Alright, so Advent of Code Day 5. A new day, a new exercise, and a new reason to practice Swift. Let's see what they got us. Is my internet alright? Advent of Code takes its time to load for some reason. Okay, now we're talking. So, day 5. Let's go. Supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. Okay, so supplies are in stacks, marked crates. Yeah, but because the needed supplies are buried. Okay, yeah, so we have a stack of boxes, I assume, and the stack of boxes is called crates. The crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. Is it Hanoi Tower? To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crane are rearranged, the desired crates will be at the top of each stack. They don't want to interrupt the crane operator during this delicate procedure, but they've got to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, your puzzle input. I probably want it here so that I can see my chart. Okay, so the puzzle input. This is the stack 1, stack 2, stack 3, and we have NZ, DC, and B. And in this example, there are 3 stacks of crates. Stack 1 contains 2 crates, and crate Z is on the bottom and then on the top. Stack. Stack 2 contains 3 crates from bottom to the top, MCD. And finally, stack 3 contains single crate B. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different to a different stack. In the first step of above arrangement procedure, one crate is moved from stack 2 to stack 1, resulting in this configuration. So we are moving D from 2 to 1. Okay, in the second step, 3 crates are moved from 1 to 3. So yeah, first is empty. The crates are moved one at a time, so the first crate will be moved to... Okay, so those are reversed, D and Z. Okay, then both crates are moved from stack 2 to stack 1, but once again those are reversed. Finally, one crate is moved from 1 to 2. Okay, the elf just needed to know which crate will end up on top of which stack. In this example, the top crates are C and Z in stack 3. So you should combine this together and give the elves the message of CMZ. After the rearrangement procedure completes, what crate ends up on top of each stack? Okay, so I wonder if we have three number of stacks, or we can have more, maybe. And do we have just one? Yeah, I think we just. So probably wanna take a look at the puzzle input. Well, this is okay. So the first challenge is to parse this. Parse the input, and we can have quite a bit number. Well, we can have 9 in this case. Right. Well, so the first challenge would be to. I'm gonna launch my playground. So the first challenge is to parse the input. I'm gonna drop the sample into the file here, and oh, it's the wrong one. This one. And let's see if we can get it going. I'm missing a space. Okay, so here I'll probably be careful to remove the last. Can I even remove last? Okay. I'm not sure if I can, but yeah. So first of all, I probably wanna try. So these are the instructions, and these are the initial state. First of all, I probably want to separate them, but I think I should be split in this line by line, maybe. Right. And let's see what is our last is here. I wonder if I'm having the trailing empty line or not. Yes, I do. Okay. Well, anyway, we can start with splitting inputs. By this, maybe. By this empty line. So what I have to erase or maybe it would be simpler to split like this, contents, and have let what? Stack input lines would be contents, components. Separated by this, and move input lines or commands, right? Would be the second item separated like so. Here, probably check that contents count equals 2. Else I want to bail out right away. And let's take a look at stack input lines. Okay. So how do I want to do this? Well, easiest would probably be to kind of rearrange the text like from vertical to horizontal. if we could, you know, like move n, z, and 1, and then d, c, m, 2, if we have this like this would probably be the easiest. Let's see if we can do this. Okay, this UI, that's not what we're looking for. Okay, looks like people are doing this manually. I was thinking that maybe there is a built-in way to do that. Yeah, I definitely don't want to use SIMD from Accelerate Framework for that. Well, okay. Right, so what if I'm doing the manual solution? I need to know the position like for instance here we can have I could try to split by elements so I could get this braces, which wouldn't really be super helpful. Okay, are the crate names one syllable? Yep, they are one character. Because like nothing really prevents me from removing, you know, all the extra data. I don't need any spaces here, right? And I don't need any square braces. So I can clean those here right away, for instance. What if I do filter? No, I want a map. No, I want a filter. So I probably want to grab character set alphanumerics and contains this. Okay, grab Unicode's color. I'll just grab it first. Should be fine here. Can I do first? And let's do the bad thing. Okay. Yeah, I probably want to keep the new lines as well, right? Or I can map and filter components after I split by lines. But I want to keep the spaces. So I need sets, join like join character set, union. Okay, union and character set, white spaces and new lines. Right. So I can do like this, and I can check against this larger set. Let's see if it works. Right. Okay. Perfect. So this resolves several problems. First of all, I guess we don't really need this 1, 2, 3 like here in our input. Yeah, well, 1, 2, 3, 4, 5, 9, perfect. So since they are not named, I can also just, drop the last line. And now I have each character yeah, I just probably want to keep new lines. Right. No. I need white space to know on which position. Okay, so how are we going to represent the stacks? I think, well, we can start simple and just have a two-dimensional array. So stack state, for instance, could be a I'm gonna regret using characters, right? Like so. And now we can try to use stack input lines. Probably want to do this here so that I initialize the number of empty arrays. So this would be array, repeating empty array, and the count would be the stack input lines first count. So in this case we'll have like 3 empty arrays to start with, right? So stack input lines. Let's iterate over. We can just do for each. And now if we take once again for each, we want to do enumerated. Here we probably want to do enumerated. So this is like line by line. This is going to be like this line and this line and this line. But each character we need enumerated so that we have like its index, which would tell us to each stack to put it, and it would be the container name, crate name, right? Okay, so now what we can do is take our stack state, and for the index we can append the crate name. Would it compile? And of course we gotta do this only if crate name is not a white space. yes, okay. 1, 2, 3, 4, 5. Why do we have 5? Because we contain white spaces, right? So let's extract and have number of stacks here, which would be filter is included. Once again, character, we want to do alphanumerics only. No, but this is the first line. We can use the last line though. Not even alphanumerics, just letters, contains this, and we can do this by number of stacks, sorry. So cannot convert value of type string element, aka character, right? I want to use color first. We gotta do it first. And I really don't like this for some wrapping thing. Okay, so we have number of stacks here. We want to skip, yeah, but here we are getting this input on this parsing for loop, right? We are getting the potential element, the space, then potential element, then space, the potential, well, the crate name, right? So we can probably guard against that by removing every other element, right? This would be best if we could do this here, then we wouldn't need this removing once again here. So how can we remove every other element? Is there a main function for collection? Swift take every other element, something like stride maybe. I can enumerate and judging by filter, you know. Yeah, so they're using stride here. I think it would be easiest to enumerate this and then to filter, and then as included would be this is it, index and item in, right? So we have an error. Value of tuple type enumerated sequence has no member enumerated. And then I can just map by element. No, I gotta do map. And I'm gonna filter and map. Because this is like line by line, right? And here I do enumerated. Right. And then once again I do map again to return just this. And we can just do count. Would it work? So we want to include, okay, so our input lines are 0, empty, empty D, and then NC, oh, okay, so we have no third index here, right? NZ, NC rather, NZMP. So we have 3 stacks and space space D and C Z M P. Space D space, it should be space D space, but it's space space D. Why is that so? How's our first line looking here? probably still want to print this. Well, it looks okay. And instead of doing this, I can just like map this with printing 0 and then return. It's still okay. We have this malformated or something. Is it a tab? No. Did I do something wrong? Let me just retype this. Maybe something with formatting is off. No, we're still having D in the trailing position. Why it is so? I wonder if the filter does something wrong. Maybe if we'll do this, it's gonna get better. No. Yeah, I probably wanna do the components separated first. Maybe something will affect how I filter this. Well, okay, we have split this line by line. Now, let's re-engineer this part. Now we want to map on each string. We will be replacing input with this and this, and then what we can do, and then we can enumerate it and filter and map. Will it give us something that we want? Yep, it does, but there's this will drop last probably here. Interesting that we don't have any numbers. Okay. Okay, so we're clearly getting this space D why is that so? Okay, so this is our input line. Let's see. It has 1, 2, 3, 4. So okay, so this would be opening brace, element, closing brace, space. So like 1, 2, 3 items, space. Yeah, okay. So opening brace, crate name, closing brace, space. Okay. Well, okay. What if we don't filter out the elements, but rather just take the ones that when it just like cherry pick them? Because I assume what happens is we remove this, then we take first, take second, and then we get D, right? So that's probably the reason for the error. So what if we nitpick this instead? What can I do? I know that the element of each would be 1. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1, 5, 9. So we're basically adding 4, right? So we should strike probably, right? So we do 1, 2, like stride from 1 to count by 4. Let's print what would we get. Okay, let's are these the correctnesses? 1 and 5, 1 and 5, 1, 5, 9. Okay. Yep, seems correct. So now I can check the stride, and this is basically our index and map. We have line here, and we can just do line by this index, and this should do the trick. Right, there's got to be line count. Subscript cannot, so we split this to array. Right, and we can probably split this to array before, so that we wouldn't do this many number of times. Okay, so this is good. We're getting somewhere. Now we have a problem here with the number of stacks. We gotta use the last. Because like yeah, can we have an empty stack? Well, not in our case, because like if a stack state would be empty, I should probably have kept this line. Well, or I can just do max. Yeah. Max by like so, and count. finally, I have input. So it's not really a stack. Probably gotta be reversed because like I have head of the stack should be at 0. Well, base of the stack should be at 0 index, right? DCMP. Okay, so right, okay. ZNMCDP. Okay. Finally, we got somewhere. So this is first. Now we gotta parse the crate inputs. The command input, sorry. And this gotta be easier. Let's see. Okay. So we take just contents, we do components separated by the lines, then we map each one for we can do replacing, right? Occurrences of move with empty space, then we can do space from with empty space, and well, basically 2 once again to empty space, and this would be commands. So now we should have, let's also print commands. So now we should have strings, but we want integers. Yeah. Well, I'll also filter. Can just do not empty. We have 4 commands, right? Right, perfect. Now we can map again, or rather we can, yeah, well, so this is a cleanup, and here we do map. We can just do and it. Okay, so it doesn't want to accept, let's do string in it, and then we do and. So we have a bunch of optionals, so we do compact app. And now we have a list of commands. So since this is quite a, well, this is throwaway code, I can adjust indices right away because I index zero-based indexes, but we here those are start with 1. So first is number, we don't change that. Let's adjust them here. So we denumerate it and then map. So if index is greater than 0, we return this -1. Otherwise, we just return the index, and then we map again. Yeah, I think this should be good. So this reduces the indices. 1. Okay, so we have commands, and commands are should I define the structure here for a command? So yeah, let's do this. Got it a little bit easier. So we create a command. Right, and this index from would be this one. Index 2 would be this one. Number of crates would be this one. Gotta subtract one from indices. Oh, I have some chat message. This is spam, right? A promotion for channel, blah, blah, blah. Yep, it's spam. So I'm gonna close this one. Okay. Okay, we're again somewhere. Let's print it and verify. Is it hung? It's hung, right? I'm gonna copy this, I'm gonna close this, and I'm gonna restart from TB. Okay. What if we do this? Okay, it does not really like something about the last change, but it keeps hanging. Let's see. Set it init. Okay, let's call this crane command, right? Would this be good? It's still spinning over there, so I close and reopen this one more time. I wonder what's up with that. Okay, so this works, but what if we do this instead? What is up with that? Can I remove this one? No? Okay. Okay, so we have print. It works. If I remove this one, it would work. I hate when Xcode does this. So what's up? Okay. Okay. We'll do this. So there, we had some compiler quirk. Index 2 equals this one. And yeah, now it's like working. So from what are we doing? From 1 to 0, we're moving one crate. From 2 to 1, one crate. And then from 0 to 2, we're moving 3 crates. And then from 0 to 1, we are moving 1 crate. Finally, yep. Okay, now we're talking. So now we can do commands like crane commands for each, and we have a command in. So we take what from, we need stack state. I'm gonna elaborate on this command, right? Command from, and we do this crates. We want suffix. We want to command the number of crates, and we want to reverse them, right? Or we reverse them when we add them. And now we are adding them to where? Command index 2. Append grades reversed. And now we want to do crane man's map. Just take the last element. And we want to append this. Sorry, not mains. We want to stack state. Yeah, contents of. This wrong. Yeah, we don't want suffix. We don't want suffix. We want to remove or drop last. Or remove. Yeah, we can take suffix, then we can take this, and then we can say drop last number of crates. And still CZ, because like this returns something. This is not mutated method, but we can reassign. CMZ. Okay. And we can do string from this one. It doesn't want to. Okay, well, we can do joint without lazy, please. Just joint. Okay, so let's get a string. CMZ. Thank you. Now let's try. With the input. Oh my, oh my. So where are we printing wonder? Yeah, this stack state. Let's also print crane comments. Okay, let's see which one causes the issue. For -1. So this is number 15. Well, number 16, I guess. Maybe something how I handle characters. Let's double check creation here. So replace, and we have a line. Yep. So this works for single-digit commands, but it breaks for multi-digit commands. Okay. How can I do this? Well, I keep spaces here. And here we can do component separated by space, and then it, I guess maybe something like that. This should fix it. So let's see. Ooh, yeah. Well, this was challenging, and this is just the part 1, and it was challenging. It was challenging, and it was just part 1. Well, let's see if we can accomplish part 2. I seem to still have one viewer. Well, that may be something like this. Okay. Let's go to part 2 then. Well, this was something. How long am I streaming? 1 hour already. Okay. So part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't crane mover 9000, it's a crate mover 9000. It's a crate mover 9001. The crate mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates and what's again considering that's gonna be, I guess. So as before, however, action of moving 3 crates from stack 1 to 3 means that those 3 moved crates stay in the same order. Finally, a single crate is still moved. Okay, well, this is easy enough because like the parsing has been the most challenging thing. Well, this change means that basically we are not reversing the crates, as far as I'm concerned, I think. And this should be it. Yep. Okay, yeah, this has been challenging. Due to parsing of the system, this has been challenging. Ooh, I'm gonna end this stream probably and go ahead and take a look how other people did this exercise. So thanks for watching. If anybody watched this, and I'll probably do in next day tomorrow. Bye.